First things first, the difference between today and yesterday is that today you'll have remainders. So you'll no longer have the security of knowing you're finished and correct at the very end because you have zero remainder. On these, you will have a remainder, and you have to do all the little arithmetic correctly to get the correct remainder. The only way of knowing if your remainder is correct is to do the check, which I'll show you briefly here with old-fashioned elementary school version, and then we'll do the same thing but with polynomials. So if we had a remainder here, like you're dividing 19 by 4, goes in there 4 times. 4 times 4 is 16, subtract, remainder is 3. How can you check when you have a remainder of 3? All right, so what you do is, of course, you still want to get this dividend as the answer. So you take your quotient, your divisor, multiply those, and then you add the remainder. So the way to get 19 would be 4 times 4, and then add the remainder, and that gives you 19. That's how you know your answer and your remainder are correct. So just didn't have this step yesterday. Now we do just have to add it on the end. Okay, so let's look at a few of these. Trust your instinct. You'll probably know how to do most of this just fine. It's just being careful on the details, like with the negatives. Okay. Of course, write down the problem correctly, copy it down. That's not done right, then we know it will be wrong. All right, so let's see here. X times what gives you x squared? That's x, and make sure you write it directly above the other x. So if you look at a column, they always should be the same exact exponent. So don't write it above the x squared, in other words. Put it above the x. So x times x is x squared, switch the sign. Negative x squared. X times 2 is 2x, switch the sign. Negative 2x. There we go. 3x minus 2x would just be x. And then repeat the process one more time. So x times what gives you x? Plus 1. 1 times x, x. Looks like I forgot to bring down the minus 15, right? And then 1 times 2 gives me 2, but change the sign on both of them. So there we go. So we'll end up with the remainder of negative 17. So always multiply, change the sign. Don't forget to change the sign before you write it down. So it's like a two-step process, then write. Now, just like we did before, we multiplied 4 times 4 and then added the remainder. So we're going to do the same thing, but with polynomials. All right, so it's going to be x plus 1 times x plus 2, and then minus 17 as the answer. X plus 2 times x plus 1, and then minus 17. And that would be the correct format of your final answer right there. Now it does have a place to check. I'm going to have you guys check some of them, not all of them, even though there's a check on every single one. I'm not going to have you check every single one because it's somewhat tedious, and we don't want to spend too much time doing it if you're already familiar on how to do it. So I just want to make sure you guys are able to do it on a quiz or a test when that part comes around. Okay. So once again, we're going to do a check, multiply it back together, and at the very end subtract 17, and we're looking to make sure it matches the dividend. So we'll know it's correct if all 3 of these match exactly the same. So a little review of multiplying. So we get x squared plus x, and then plus 2x, and plus 2. And that minus 17 is still there. So we have two sets of like terms. We have the x plus 2x, and then we have the 2 minus 17. Simplify both, and you have x squared, x plus 2x, 3x. 2 minus 17 is the minus 15. So these indeed do match, so we know it's 100% correct. So this is what you want to do on every quiz or test problem for sure to make sure it's absolutely correct. This one's a little shorter, the other ones will be a little bit longer, but you know, it's not definitely difficult, just takes a little bit of time. Sometimes checks are short, other times they'll be a little longer. All right, so that's the process. Let's just do a few more, get the hang of it. Okay. This is a little different because we're dividing with a trinomial, using a trinomial, which is perfectly fine. It's just that when we're doing the steps, instead of multiplying twice, we'll multiply 3 times. 3x is 4x squared plus 6x plus 8 There we go. Okay, so same idea, x squared times what is x to the third? X, and where should I write that? Above what number? Yeah, it's an x, so you find which of these is just the regular old x, so here's 6x, so it belongs right above there. So the exponents will always line up. So we have x times x squared is x to the third, switch the sign, minus. X times x is x squared, switch the sign, minus x squared. And then x times 1 is x, switch the sign, minus x. So we just have 3 multiplications, you know, distribute 3 times, and that's what's new and different here. Although it should be fairly intuitive. Okay. First term cancels, that's good. Simplify the next two, so we'll have a -4 and -1 would be -5. X to the second, variable doesn't change. And 6 minus 1 would be +5. And then lastly, bring down the next term, which is just +8, and repeat the process. All right. So what do we need here? X squared times what is -5x squared? Yeah, just -5. So -5 times x squared, switch the sign, plus 5x squared. -5 times x is -5x, change the sign, plus 5x. -5 times 1 is -5, change the sign, plus 5. Got our first terms canceling, which is good. We have 5x plus 5x, which is 10x. And then 8 plus 5 is 13. So we have a remainder of not just a number, but of an expression 10x plus 13, which is fine. And be careful here, it's tempting to say, well, we got a 5 and 5, they cancel out, but they're both positive, so that's why they add them up. So we have our divisor times our quotient plus the remainder. There we go. Do you guys want to go through another check, or are you comfortable with? Okay, or I want to do it. Yes, do it. Okay, let's go through and do the check. So we need to multiply these two, get that answer, and then at the very end, add 10x plus 13, and that should equal the dividend right here. So if I don't get all 4 of these to be exactly the same, I know something is wrong with the answer. So let's multiply. I'm going to multiply these old-fashioned ways. Since we're doing old-fashioned division with long division, I'm going to do the old-fashioned multiplication as well, where you stack them. Right. So go ahead and multiply them. Same exact way. It's basically a distributive property. You might not remember this, when you did the multiplication, like with just two random numbers. I just picked them. But when you guys learn to do this, you're basically doing distributive property. You're doing 5 times 4, 5 times 7, 5 times 1, 3 times 4, 3 times 7, 3 times 1. You're distributing. So same thing here, just that we have variables. So negative 5 times 1 is just negative 5. Negative 5 times x is negative 5x. Negative 5 times x squared is negative 5x squared. And then we repeated the next step. X times 1 was just x. X times x was x squared. I'll put a plus there. And x times x squared was x to the third. And we added those all up. So we got x to the third minus 4x squared minus 4x and then minus 5. And you can see that these don't match each other, right? But that's because we haven't done the remainder yet. So let's add the remainder now to it to complete it. Do one more step. So now we have x to the third, right? Minus 4x squared, those don't change. But now we have 10 minus 4x, 10x minus 4x, that's 6x. So now you can see it matches 6x here, and we have 13 minus 5, which is 8, which matches there. So now we can see that my dividend and my check come out to be the same. So 100% we are correct. As I mentioned before, you can see these checks are rather intense. They take time, they take attention to detail, almost as much work as doing the division itself. That's why I'm saying right now, I want you to do a few of these on your own to make sure you can do the check and you're comfortable with it, but don't feel like you have to do it on every single problem. If you know how to do a check and you could do a check on a quiz and a test, just stop there and say, I'm good. Okay? Do as many or as few as you need be. All right, so that's 1 and 2, straightforward, just with remainders. Let's look at 3 and 4. There's some slight differences. Start by number 3 just by watching, don't write anything down. I'll let you guys spot what's different about these and what we can do to fix that issue. There we go. So if I start this problem as normal, I'm finding 3x squared times what gives me 15x to the third, right? And I'll come up with 5x. 5x times 3x squared is 15x to the third. So if I switch the sign for the first term, I'll have the negative 15x to the third. And then I have to distribute to the other term. So 5x times 6x, switch the sign, will be negative 30x to the second. And 5x times 1 would give me 5x, which the sign would be negative 5x. Right? Go ahead and do this. These cancel out, and then I add these up, right? What is 8x minus 30x squared? Can do it, right? What's negative 12 minus 5x? Can do it. So that's the issue we have that's different on here, is that since the divisor here, you see how it goes from x to the third to x to the 1, it's missing x squared in the middle? That's what we need here. We need an x squared here so everything lines up perfectly. So what x squared value could we use? Since we don't have an x squared at all, what's a good value to use here? How about 0? Put in a 0x squared, right? And that will solve the issue. Now, as I mentioned before, not to write it down because I knew this was going to change, now go ahead and write this down. Right, so you want to make sure your dividend here always goes down, decreasing by 1 for each exponent. They call it descending value, descending order. So we have 3, 2, 1, and then 0. And if there's 2 missing, let's say if I had just 15x to the third minus 12, I'd put a 0 for the x squared and a 0 for the x. I'd do both zeros. So you can have multiple of these as needed. But other than that, the rest of the steps are exactly the same. You just have to be careful when you're missing a value. So I can use the same value as I did before, which was 5x. Repeat the process. Get negative 15x squared, and I'll get negative 30x, oh, no, sorry, negative 15x cubed minus 30x squared, and then minus 5x. And now you can see how they are all lined up perfectly. X squareds are underneath x squares, x is underneath x, so everything works just fine. So at any time on any problem, if you look at any column and it's not the same exponent, that's a sign to stop, go back, find out what's missing. So we'll get negative 30x squared plus 3x, bring down the minus 12, and repeat. So we need to multiply 3x squared times what to give you negative 30x squared? Negative 10er. So multiply, switch the sign. Get positive 30x squared. Negative 10 times 6x is negative 60x, but switch the sign, it'll be positive 60x. And negative 10 times 1 is negative 10, switch the sign, positive 10. Got a cancellation, and our remainder will be 63 minus 2. All right, but do write your answer. I haven't written an answer yet, we did the work. So divisor times the quotient and plus the remainder. I won't do the check here, but you can and verify. But if you were not to do the check, this would be the answer you would stop with right here. Okay. So on this one was the divisor, oh sorry, the dividend that skipped one of the exponents. So we had to insert that in. Right? The next one, number 4, you'll see it skips an exponent in both the divisor and the dividend, both of them. So like here you can see it goes from x to the 4th, x to the 3rd, skips x to the 2nd, goes to x, then 13. But also over here, the divisor, it goes from x squared directly to 8, and it skips the x. So what we're going to do, though, is not change the first part. You could put a 0x plus 8, but most will find it unnecessary. But definitely for the dividend here, go ahead and do the same thing we did on the last one and put in a placeholder of 0x squared. So in other words, no matter what the situation, you only need to really fix the dividend by putting in a filler as needed. Now here's what's going to happen. See, x squared times what is 6x to the 4th? What was it? 6x squared, so it goes above the 0x squared, right? So 6x squared. Multiply, get 6x to the 4th, change the sign, negative. 6x to the second times 8 is 48x to the second. Where should I write that? Below the x cubed or below the x squared? X squared. So we were going to leave this blank, right? Because once again, in the column, you should have the exact same exponent. But when we multiply these two together, we don't get x to the third, so we're not going to write it underneath the x to the third. Move it over here, negative 48x to the second. So that's the second part, 2 of 2, that's different when you're skipping a term in the dividend here. You'll see you'll have a space. Now, if you went ahead and did this, and you, instead of doing x squared, you put x squared plus 0x plus 8, like you put in a missing term like we did here, what will happen is you'll just get a 0x to the third. So whether there's a 0 here or there's nothing here, you probably do the same exact thing. So that's why it's not really worth writing this part out and changing it, just so we can put a 0x to the third here. All that will happen is that will cancel out. This will just drop down, or add 0 to it, and it'll stay the same. We'll get negative 48x to the second, and then we'll drop down to negative 9x. And repeat. Okay. So we need to, let's see here, get an x cubed. We have an x squared, so we should probably multiply by just x, right? So x times x squared is x to the third, change the sign, negative. X times 8 is 8x, change the sign, negative 8x, right underneath the negative 9x. So once again, we have a space. Just like the first time, we'll have it again here. So we're going to drop down the negative 48x squared. That won't change. Negative 9x and negative 8x will give you negative 17x. And we can drop down the 13. So it's not the same, but it is similar enough to know, compared to all the others, that we can complete this. Question? Not there yet. Let me finish this first. Sorry. So we need x squared times what will give me negative 48x squared. We'll get, negative 48. So negative 48 times x squared will give me negative 48. Switch the sign, be positive 48x squared. And negative 48 times 8 would be, let's see, write it out. $32 plus 6 would be 38. So we're going to have plus 384. So this could be a little misleading because we're used to thinking, if the numbers get too big, that must mean there's a mistake. But in this case, no, we can have a remainder of negative 17x plus 397, and that is the correct remainder. Okay. So I'll leave it up to you if you want to decide to check this one. You want this to be one of the ones that you check. But if not, then your final answer will be in this format. And then with the remainder at the very end, negative 17 x plus 397. There we go. I'll leave it with that. We can look at the back real fast just as a reminder for the end behavior. So 11 through 14 asks you just to graph well, the graph's already there, so basically identify which is which. We got four equations, 4 graphs. They're very similar to each other. You might remember that if it's, you can tell the direction of the end behavior by looking at, what was it? What changes? Yeah, the leading value, right? The leading exponent here, and you're looking at whether it's positive or negative. So you can see 2 of these are negative and 2 of them are positive, right? So that's why we have 2 that go this way and 2 that go this way. Which is which? $11 and $13 will be C or D, right? So x to the third starts low, finishes high. And if you take the negative, it reverses, starts high, finishes low. So you know for sure 11 and 13 are C or D, 12 and 14 is A or B. Now how can we tell which is which? Right? So that's when we look at the y-intercept. So we can see here the y-intercept is positive, over here the y-intercept is negative. So we have a positive end behavior with a positive y-intercept, which would be C, right? This is going up, starting low, finishing high, and the y-intercept is at +4, which means this is still starting low, finishing high, but the y-intercept is at -4, like it says here, -4, so we know this is D. So notice how to do this problem, we did not need any of the middle part. That's not needed. If you already have the graph, you do not need this part to identify the graph. It's just by looking at the end behavior, by looking at the leading coefficient, and looking for the y-intercept by looking at the end coefficient, the y-intercept. Okay. All right, so I'll leave you with that, and you guys can work on 5, 6, and the backside. And you got about 20 minutes to really, probably finish up most of them, maybe do a few checks if you have the time.